Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we're going to be exploring the holographic model of reality and its implications for ourselves, our bodies, and the world around us. With me today is Michael Talbot, author of several books including Mysticism and the New Physics, Beyond the Quantum, Your Past Lives, and most recently, The Holographic Universe, as well as 3 novels. Welcome, Michael.
Thank you, Jeffrey.
It's a pleasure to be with you.
Nice to be with you.
You know, one of the things that you point out in the holographic universe is that this is a model that's been around now for a few decades, but it's really beginning to show its power in explaining many, many areas of personal experience and science at the same time. Can we talk a little bit about how the model developed?
Sure. It was developed by two men, University of London physicist named David Bohm, who was a former protege of Einstein, and a Stanford University neurophysiologist named Carl Pribram. And they worked independently. Pribram was studying memory and found that there's evidence that the brain operates holographically. And Bohm was studying subatomic physics and found that on the subatomic level, the fabric of reality seems to possess properties that are reminiscent of a hologram. So if you put those two ideas together, that our brain seems to be holographic and the universe is holographic, it suggests that maybe it's compelling evidence that the universe may be a kind of hologram, not that it's literally a hologram, but that it's a good metaphor or way of understanding the universe.
Now, when you say it's holographic, what do we mean, really?
That, in a nutshell, that reality may be more plastic and changeable, like an image, than a solid construct, a sort of sticks and stones world. It has a couple of other implications, one of which is that a hologram has an unusual property. If you take a piece of photographic film that has a holographic image encoded in it, that means that you cannot see the image with your naked eye. You have to reconstruct the image, you have to shine a laser through it. So if you have an image of a rose in the film, shine a laser through the rose, you'll get a three-dimensional image of the rose on the other side. You cut that film in half, shine a laser through each piece, you'll get a whole rose out of each piece, which is a very unusual property and sort of boggles the imagination at first. Cut it in 4, you get 4 roses. Cut it in 8, you get 8 roses. So if the universe is a hologram, it means, as William Blake said, that quite literally you can find the universe in a grain of sand, that every portion of the universe contains some semblance of the whole universe.
That's very profound.
Very.
It's mind-boggling, and you know, one of the things that you point out in a footnote of your book that I would like to mention is that this doesn't apply for many of the kinds of holographic images that are popularly sold as pendants and the like that don't require laser light.
Right. Every talk I give, someone comes up and says they cut the hologram in half on their credit card and ruined it and didn't get the effect. And it only applies to those images that you cannot see with the naked eye, that you have to reconstruct.
If you were to look at holographic film, it might look like ripples on a pond unless the laser light is shined through it.
Right. There's no decipherable image in the film, and it very much does look like ripples in a pond, like when you drop pebbles into a pond. There are all sorts of little circles.
They're called interference patterns.
Right. The same as when you drop 2 pebbles in a pond and the ripples crisscross. That is exactly what is in the film. It's the crisscrossing of the laser light that's recorded on the photographic film.
So there's the sense about a hologram that there's 2 levels. One is this 3-dimensional image that's projected, and it can look so real that you want to reach out and touch it. And in the other level are these interference patterns.
Right. That reality in a hologram can manifest in 2 ways: as a concrete image, or as this sort of indecipherable blur of energy. And an analogy to this is when you're watching Johnny Carson on your television set. That's really, his image is encoded in 2 ways. One is as the concrete image on the TV set. One is as the blur of radio waves permeating the living room. And if the universe is a hologram of some sense, in some way, it suggests that there may be 2 very drastically different levels to reality, that the concrete reality we see, you know, when we look at these chairs and at the trees and the clouds and everything like that.
Our bodies.
Are just one way that reality manifests, and that at some deep level there's a level of reality where everything dissolves into an ocean of energy that is holographically interconnected, where every portion of the universe is contained in every tiny area of the universe.
So that implies that this notion that we go about our everyday lives with thinking of ourselves as separate from each other and the cup is separate from the coffee that goes in the cup, that these notions are somehow, what would you say, superficial or contradicted at a deeper level?
They're artificial, definitely, and Bohm really stresses this, and it's a very interesting notion because in our Western way of thinking, we're so attached to the idea that when we come up with a concept like an apple or an electron or whatever, that exists out there, and we forget, it's kind of like fish unaware of the water in which they swim, that the conceptual pigeonholes we use, words, to describe reality, are phenomena inside our head. They're not out there. And most of the time this is a philosophical quibble, but when you get down to quantum physics, and this is one of the reasons that Bohm came up with the holographic idea, it starts to have real effects. And one of those is it's been discovered that if you take two subatomic particles like electrons, that in certain instances, when you do something to one, it will always affect the other, no matter how far apart they are. It's kind of like stories that you've heard of identical twins where when one is hurt, the other feels the pain. And the problem is that we can find no process known to physics that explains how these could be sending a signal back and forth. In fact,
because it would have to be faster than the speed of light.
Instantaneous. It would have to be an instantaneous signal, and Einstein's theory of relativity said you can't have instantaneous signals because it would mean that you could violate the time barrier and conceivably call your grandfather and tell him not to marry your grandmother. And most physicists say, well, this would be just too troubling to incorporate into a rational picture of reality. Bohm explains it in a different way, which is a very interesting way, and he says, if you imagine that you've got an aquarium in which you have a fish swimming, you have a TV camera facing the front of the aquarium, one facing the side of the aquarium, and you have a monitor attached to each camera. Now you also imagine further that you come from a culture that's never seen aquariums, never seen fish, never seen monitors or cameras. All you are privy to is the two images on these screens. He says that maybe, you know, if you look at these two screens, you're going to see a side view of a fish and a frontal view of a fish. And because you don't know what the deeper reality is, the reality of the aquarium, you may assume that these are two separate things. But
two different fish.
Two different fish, two different objects. But every time one fish moves, the other is going to make a corresponding movement. And you may then jump to the conclusion that somehow the one fish is signaling the other or communicating the other to say, hey, do this, instantaneously. And Bohm says this is what we've done with subatomic particles, that we assume that an instantaneous communication is going on when that's not really what's going on at all. At a deeper level, a very holographic level of reality, every particle in the universe collapses to a sort of cosmic unity. They're not signaling each other. They're like that fish where there's the level of the aquarium. And so what that means, talking about words, is that there is no separation between electrons. Furthermore, there's no separation between people. And this has all kinds of very boggling implications, one of which is that we've always tried to understand, for example, psychic phenomena, like how could I get information out of your head in my head, as some sort of signal going back and forth. But if we're organized, if we live in a universe that's organized holographically, you no longer have to tackle it that way. It could be that I have the entire universe and every neuron, every cell, every atom, every electron in my head, and you do also. So when we can access that, we can access information that seems to be beyond our normal sensory reach.
Well, you know, I'm very interested in psychic phenomena, and I know you've had many personal experiences,
Right.
and I want to touch on it, but this is not a model that was developed in order to explain psychic phenomena. And I think to neuropsychologists like Carl Pribram, the fact that it happens to provide an explanation for psychic phenomena is almost a bit of an embarrassment, that he developed the holographic model because he was trying to come to terms with memory.
Right.
So let's talk about that.
Sure. Pribram was working under a very famous neurophysiologist named Carl Lashley, and it was at a time when it was believed that memory was stored in a specific spot in the brain, and there was something called the proverbial grandmother cell, that there was literally a cell in your brain that contained the memory of your grandmother, what you knew about your grandmother. And so they did a rather gruesome series of experiments for animal lovers, but it came out with some very profound information. They took rats and they taught them how to run mazes. And then they would surgically remove various portions of the brain, Pribram and his mentor, Carl Lashley. The reasoning being that if they could remove a portion of the brain and the rat could no longer run the maze, they'd found the area of the brain where the rat's memory of the maze running ability was encoded.